This presentation's about some of the work we've been doing to optimize cloud image building, and there are a few tips and tricks as well, which you might find useful if you're kind of working in secure and enterprise environments. So I'll get straight into it. What makes a good OS image for Openstack? So obviously you're going to want a very clean install of your operating system, and you're going to want to make it quite minimal as well. Once you've built your image, you're going to want to perform some system preparation. You'll definitely want to pull out all the MAC addresses from your build instance. You're going to want to clear out your log files and any other unnecessary data that's been laid down during the installation process. There's a great tool for that, written by a chap not too far away from me here called Vert Sysprep. And we use that heavily to do that sort of thing. There are a couple of gotchas, and I'll come to those a little bit further in. Obviously, smaller images are going to launch faster. So for the best performance, you definitely want to sparsify your images, i.e. make sure that you don't have lots of unused blocks in your disk image. So sparsify is a tool for actually making those unused blocks not actually take up any space in your image. Then you can also compress your images as well, which will take them down even further, and there's a tool for that. Again, part of the same libguestfs toolkit called Vert Sparsify. Another really important thing is if you want to have one image that you can deploy to any instance, you're going to want to make the root partition resize automatically. So when you build it, you maybe build on a 5-10 gigabyte instance. Later you may be launching that into a 100 gigabyte instance. So there I will also show you a trick to actually make that resize automatically on the first boot, no matter what size of instance it comes up on. A little aside on that, the tools currently don't seem to handle LVM very well. So if you are going to use this trick to resize the image, what you actually want to do is to have a single partition for your root file system, and not have a boot partition, and also not put swap into your base image, because you can add that in later via the OpenStack flavors. I can't hear you. Here you go. I'm not coming forward to that speaker. That should all be deaf in no time.
It sounds like with that scenario that if you're using an MBR type thing that is primary partitions, does it cope with GPT?
GPT?
Yeah, it's the thing.
Yeah, it doesn't use GPT.
But it
GPT,
works as well, yeah?
I would presume so.
Okay, cool.
Yeah, so you want to have a single slash partition just as a raw native file system on your image, and in CentOS, obviously we're on quite a reasonably old kernel now, and one of the problems with that kernel is that once you've mounted a file system on an image, it can no longer read the partition table. So this is something that's fixed in Linux 3.8 or later. So hopefully we'll kind of, I don't know if we're going to get that for RHEL 7, but we might. But in the time being, there's a module called Dracket Modules Grow Root, and you can install that from your initial kickstart. And what that will do is when your instance boots up for the first time, it will see that there is space for the root partition to grow into, and it will grow into that root partition before it actually mounts and boots the operating system. Then later, the rest of your system, Cloud Init hooks can come in and actually resize online the file system into the newly grown partition. So that's quite a useful trick. As I just mentioned, you're going to want some post-boot hooks as well. So for that, the standard is Cloud Init, and that's available in the EPEL repo. That not only handles things like resizing the root file system, that will also add users or run any kind of scripts that you might want to run. So it's very useful. Also, one of the tricks that we like to do is to incorporate a file system integrity tool, such as AID. Well, AID's the one we use, and during the image install time, we actually create an AID report before that system's even been booted and seeing a user, so we know what the good kind of starting point was for that. And if we need to do forensics later, we can go back and compare the original system to the state of the system right now. Things not to do when you're building images: please don't kill SE Linux. Red Hat Dan will not be impressed, and I will get upset as well. There is a trick to actually fix any broken labels which are caused by the Vert Sysprep tool, which will go away and it will blow away your network configuration, and it will touch a few of the files. Unfortunately, that will break various SE Linux labels, and I'll show you a way to actually relabel that file system without having to touch the auto relabel file and have that happen every time you boot a new instance. Final tip, I believe as a best practice, you should avoid creating high level images. What I mean by that is, let's say you have a role such as a web server, you should probably avoid installing your entire web server stack into an image. You might be tempted to, for example, if you've got to spawn 50 of these things later, that might be one particular argument for doing that, but I think generally speaking you should keep your images as minimal as possible. So, 3 kind of good ways of creating images. So the first one, which I prefer, is to roll my own. This is a particularly good way because we generally only really create CentOS images. So we don't need to have, you know, ways to build Windows images and BSD images and all of that kind of thing. So we have a little script which I'm going to show you in a minute. If you do want to go down the more heavyweight route, there's a project called Oz, and that will create lots of different types of images for you, and is highly configurable and heavyweight and appears to be very good. I haven't used it a huge amount. The final one that I'm going to present to you is a project called Project Raindrops, and this will give you images as a service, and that is available at projectraindrops.net. I've got a little note here, !Sysprep. Again, I'm going to show you a little bit about Sysprep shortly. I couldn't find a way to make Project Raindrops perform a Sysprep image build time, and apparently that isn't implemented in the current revision that's online at the site at the moment. So, if you're going to roll your own images, here is a kind of basic set of steps that you can use to do that. So initially, as with any network install, you're going to have your install URL for your distribution. You're going to provide a kickstart file, and you're going to launch an instance and let it go through the boot process. For that, we use a tool called Vert Install. Vert Install will literally start an instance, feed it the URL and the kickstart file, and at the end, 5 minutes later, you'll have a fully installed system ready to go. Once that's done, we shut down the instance, and we run another tool against it called Vert Sysprep, which again pulls out all the MAC addresses, resets log files, and deletes any other kind of data that you don't want hanging around from your install process. Then we have a step where we fix the SE Linux labels after they've been broken by Vert Sysprep. Hopefully a future version of Vert Sysprep will actually stop stomping on SE Linux, and we won't need that step. Next, we will sparsify the image and compress it to make it nice and small, and then we've got a ready image to import straight into Openstack and launch. Once we launch our image, then we hand off to the Cloud Init hook, which will then take your image through add users, SSH keys, and then hand off. If you've got something like Puppet or another configuration management system, Cloud Init can hand off to that. So this is kind of just covering what I just said. So you start off with your boot image, your OS image. The point behind that is to get you to a known minimal good state and establish some basic network connectivity, at which point you hand off to Cloud Init. Cloud Init will resize your root file system, and it will apply some common system attributes such as your host name and your SSH keys. It may add some users and groups. And you can go further than that as well. If you don't want to go all the way into Puppet or Ansible, you can actually use that as a light configuration management system in itself. Or if you are doing some more heavyweight CM stuff, you can hand off directly to Ansible and Puppet and whatever you happen to be using. You can also use that to enroll with monitoring, enroll with your compliance systems, and anything else that you need it to do, really. Right, that must be the demo. So, I'm going to go to... Bear with me. Right. So here are the scripts that I'm going to be using. So first of all, this script is going to take an image name. That's going to be the resulting name of the image that we're going to create. It will take a kickstart file. It's going to use the QCOW2 image format, and then it's going to use Vert install to actually create that image. So it will fire up an instance with a gig of RAM and a single vCPU. It's going to use our mirror just because it's on site here, local. It's going to inject the kickstart into the init.rd file, and then it's going to boot that image and provide it with a 10 gigabyte disk. Then once that's booted, it will once that's installed, it will shut down and it will go into the Vert Sysprep stage. And one interesting thing to note here is that we told Vert Sysprep that we don't want to do an SE Linux relabel. What that means, it stops Vert Sysprep touching the auto relabel file in root, because we're going to fix that in the next step. Once that's done, we will run the guestfish command using the SE Linux switch to make the SE Linux subsystems available within the file system. Does anyone use guestfish? You know what guestfish is? Ah, this man does. So what guestfish will do is it will take your QCOW2 file, your image, and it will mount the file systems that it finds inside it, and it will allow you to interact with them. So we use guestfish to get the file systems mounted from inside the image file, and then we can load the SE Linux policy and restore all of the labels on it. And that all happens offline, which means you don't have to have the hassle of a full SE Linux relabel every time you launch a new image. Once we've gone through that process, we can sparsify and compress, and that's the end of the process, and that takes approximately 15-20 minutes. So I'm not actually going to run it. I've got one that I prepared earlier, supposedly in this window. Justin.
The problem that you're mentioning about the SE labels and Sysprep, blowing them away, do you know if there's a bug open, like a ticket open in the Red Hat tracker for that?
I don't know.
Can you...
Apparently there is, as of today.
Okay, cool. All good. Just making sure.
Yeah. Yeah, so hopefully at some point in the future, Vert Sysprep will not mess up SE Linux, so it will make that step unnecessary. So here is an image that I created earlier, and you can see that's a base system that would be about 1.1 gigs on a freshly installed image that sparsifies and compresses down to 361 megs. So what I'm going to do, I'm going to import that into, in fact let me quickly just show you the kickstart file that I used as well. So here's the kickstart file. Again, as you'd expect, it has the URL of the base distro. We also add in the EPL repo, which will give us, which bit does that give us? Cloud init. Thanks, Paul. These are all fairly standard options. So here you can see that we literally just have a single root file system on the image. In terms of packages, we install Cloud Init, the bit that comes from the Extras project, and we have the Drucut modules grow root, which will handle the initial part of resizing the root file system, i.e. resizing the partition. And we will also install AID, which is the file system integrity tool. Post-install, we will drop the EPL repo in permanently so that we can get updates to Cloud Init and any other packages that we may have chosen to install from there. And then before we shut down the instance, we will actually create an initial database of the state of the file system. So later on we can come back and see exactly what's changed. So we'll import the image. So this is calling out to the Openstack glance service to create an image of a QCal2 format. It's one I built whilst I've been sat there a little bit earlier, and that's now ready to launch. So if I go into the control panel. Right, before I go further, I will show you Cloud Init. So, in this file we have a bash script, and this bash script performs a number of steps that we can give to Openstack and say run this script inside the instance once the instance is finished booting. And in this case we have it doing various things, so it sets the host name and various bits of networking, and then it is going to do another thing that we are beginning to use a lot more heavily at CatN, and that is install the IPA client and enroll to an IPA server. Is anyone else using IPA? Free IPA?
Yeah.
Cool, it's great, isn't it? Yeah. So free IPA is centralization of your users, your DNS, your SSH keys, your sudoers, and it allows you to create a host group so you can control who can connect to which hosts and access which services. It's really, really powerful, and in the last couple of years Red Hat have done a lot of work to make it install cleanly and simply out of the box. So it's something we're beginning to use a lot more here, and it obviously supports much stronger security policies, which we're starting to get asked for by our more enterprise clients. So this script will cause it to hook up to the free IPA server, which we have running inside OpenStack, and hopefully I'll be able to log in as an unprivileged user using an SSH key. Now I'll just show you the control panel for that first. So this is the IPA control panel. As you can see, hosts, we just have the server in there at the moment. Later you will see that our guest will auto enroll itself, and excuse me, and then we have a user, me, and you can see that we've registered an SSH key in there with it. So now I will launch an instance just to show you. In the admin side we have the free IPA server itself running. So I'll now launch an instance. So I'm going to use my latest image, which actually I haven't tested. I'm going to create a CentOS Dojo instance. I'm going to use a custom flavor that I created before. So this flavor has a 20 gigabyte root disk. It also mounts another 20 gigabyte image as an ephemeral disk, and it also adds a 4 gigabyte swap image as well, which doesn't show here. I'm going to add a key pair that will only actually install to the root user, that won't install anywhere else, and I'm going to put it in the default security group, which basically allows me to SSH to it and ping it. And then I'm going to insert the customization script, which is also called user data. Cross our fingers and click launch. What it's doing now is copying that 365 gigs out of Glance onto disk and then booting an instance from it.
So while you're doing that, Mark asked me a question, which is what kernel we would ship in Rails 7. The answer is we don't know yet, but the kernel that we're shipping in Rails 7 nightly is 3.10.0.
Ooh. Oh, that's really recent, isn't it? Happy days. Right, so that's active, and we can watch it come up. So there you can see Cloud Init kicking in.
So does Cloud Init pull that script that you pasted into the Openstack admin?
Right, so what happens is that gets registered into the cloud metadata server on OpenStack. When the host boots up, it connects to that service, which is running on a well-known IP address, and it fetches the data back just as text basically, and it looks at the first line. If the first line begins with a shebang, then it will execute it as a shell script. If the first line begins with other tokens, then it will do things differently, so you can pass it config files and it will hook into modules and do really advanced things, but this is just a simple bash script. So what it's doing here is it has now gone into that later stage where it is going to install the IPA client. It's just taken a moment. It did this before, but it's working. Anyone got any questions whilst this kicks in?
Your image is currently missing a swap file or partition. Have you thought of using a swap file inside the file system?
I will show you. What I've done is I've created a flavor inside OpenStack that creates a 20 gigabyte root partition. It creates a 20 gigabyte ephemeral disk, which is just another disk that is mounted on /MNT.
All right.
But it also adds a 4 gigabyte swap partition. So once I log into this in a minute, I'll show you that we've actually got swap available to us.
Right, but my question was, for simplicity's sake, wouldn't it be better to just have a swap file inside?
So the problem you've got with that is if you put a swap file inside your base image,
Yes.
you need to be quite careful that you put it at the end of the disk, because if you want to resize your root partition, that needs the contiguous space. So you would have to calculate where you actually put that partition to give room for the root partition to expand up to it. Otherwise, you have a non-expandable root.
But when using file for a swap,
That would be fine.
Yeah.
That would be absolutely fine if you prefer to do
So
it
that
that
would
way.
be a simpler way, at least.
Absolutely.
of doing
Yeah, I mean,
it.
this is focused around OpenStack. If you're using OpenStack, then you'll probably use the tools that OpenStack provides to you. But if you're doing native KVM libvirt type things, then yes, you may prefer to use either a swap file or put swap in your image itself.
That's what I usually do. That's why
Yeah.
I was wondering why you didn't choose to use a swap file.
Just because we want to use Openstack's built-in features
Right.
for that.
All right.
really.
Fair
Yeah.
enough.
Just on that subject, I've not read. Sorry, on the subject. This might be incredibly dumb. I've not read up on it for a good while since, God knows when. Is swap still required? A small amount of swap, even with large memory
Not
machines?
required at all.
Right. Okay.
No,
yeah.
I would generally put it on just because I feel a little bit better.
Well,
adding some swap, but
historically, it always needed it.
yeah.
Talking late 90s and things, and I've always done it for safety, and I've never really
Yeah.
wanted to read the proper docs anymore. But yeah, I guess
I'm the same. I always add a little bit, even if it's just a gig or two.
just for good luck.
Yeah, it
Yeah,
just feels
cheers.
better.
Just one word. Because swap may still be required in some scenarios, it's good to have it. But when running a cloud instance, could set the swappiness to 0, so it starts swapping just when it runs out of memory, of RAM. That is.
Yeah. Again, so messing around with the swappiness parameters, I would generally do that based on the actual role that I'm giving to the machine. So if it's, say, a heavyweight database server, then I may consider turning down the swappiness. But for other things, probably just leave the defaults.
Public cloud,
Yeah,
and you have just random workloads.
performance is terrible to swap. Yeah,
to avoid set swappiness to 0.
absolutely. In a cloud environment, you don't want to swap really. Yeah.
To get an example of that, Brightbox actually shipped a lot of their base images without any swap at all. So I was just going to say, Brightbox actually ship a lot of their base VM images without any swap, or at least the smaller ones.
I completely swapping its parameters. I've tried to do that on desktops unsuccessfully, and also the VM dirty ratio parameters. If you've got a machine with a lot of memory in it, you must pay attention to that,
Yeah.
because sometimes you'll find your data is never actually shipped out to disk, and
Yes.
if your adapter goes down, your disk goes down, you find your flow. But on the context of swap, the old rule of thumb used to be, I believe, 1.5 times your RAM.
That's right. There is actually
Rule of-
a standard kind of algorithm,
Yeah,
isn't there, that Anaconda uses to calculate it.
I've retired servers which have got terabyte of RAM. Our biggest server's got 4 terabytes of RAM. You don't run them as swap. It's not. It's just if you've got that amount of RAM and you're going to swap, you've got other problems.
Yeah.
So I think those little rules have really stuck around, and they're not valid anymore.
You put your RAM, you put your swap for ZRAM.
So you can get advanced as you like, and you always come back to swap.
Yes, exactly. Cool.
Goodbye,
Got a-
swap.
Got a hand up here, Paul.
Not a question itself, but just as a heads up with regard to FreeIPA, since it was mentioned,
Yeah.
it's, in case people aren't aware, it is a full LDAP Kerberos solution tied into one package that's super easy to install and supported on CentOS or RHEL 6.2 onwards, I think it was, but let's call it current. And the mailing are really good. There's a good community wiki with lots of integration things of how to get the key tabs or how to do LDAP auth for applications that support LDAP. And if there's any particular things that aren't on the how-to that you'd like to see on there, or feel free to ping me as well, because I'm fairly active on those mailing lists, and I write up on the wiki on occasion and stuff like that as well.
I've got some questions for you after.
Cool, grab me after then.
So FreeIPA isn't really the subject of this talk. I just threw it in there as a kind of good practice for creating strong images that, especially in a private cloud environment where you're not kind of building images for 1,000 different companies. You're building images for yourself, and FreeIPA in a private cloud on-premise environment is just brilliant. It's probably one of the best features that we have available. And if anyone wants to actually have a click around and have a poke of it, then just give me a shout afterwards and I'll give you access to it. I mean, this is a throwaway lab environment, so happy to hand out the login details to it. Except it requires a VPN, so I won't be able to do that. I'll just be able to demo it today. Yeah. Cool, okay, so we've got our instance booted, I believe. Do I look on there to see whether it worked, or do I just go for the login? Let's just go for the login. So, what did I call this thing? Dojo demo. It's created the DNS as well on the fly, so hopefully it's going to resolve the name, it's going to log into it as me using my SSH key, and then I can show you around inside.
Because it needs to be root.
No, it shouldn't be root, it should be Mark. But I can go in as root. That'll be why. It worked. Thank you. Thank God for that. So you notice it has actually created my home directory on the fly as well. That was all part of the free IPA setup. When you enroll your client, you pass a switch to it and tell it to create home directories when they don't exist. So that's what happened there. So what do we have in here? You see, we've got our root partition, resized to 20 gigabytes. It was installed on a 10 gigabyte image. We've also got some ephemeral storage mounted there, and we've also got some swap available in there. For my final trick, so here we have the original AID database. I'm now going to so this just takes about a minute to scan the file system and give you a comparison of the state of the file system at the end of the installation process and what the file system has on it right now.
So is that a checksum against an existing?
Yes. So
Checksum against an existing created file or an on-the-fly.
that's right.
Process.
So what I did in the not in there. In the Kickstart file, in the post install section, you see I initialised the AID database before it had even been booted up and had any users in there, so we know that's in a really good clean state at that point. So we take the initial database then, and then that will always be the same for every instance that you boot from it. So you can obviously, you should really be archiving that off to a secure system, signing it, keeping it nice and safe. And there are tips and tricks for later coming back. I mean, you should really be coming from a trusted machine, supplying a new AID binary, just in case obviously it's been intruded and broken. Supply a new AID binary, run that, create your report, pull it off, compare it on a remote machine. So there are best practices around that, but for the purposes of the demo, I'm just going to trust that we haven't actually had an intrusion. Maybe we have. It's going to show us in a minute, hopefully.
As part of the libgestfs scanning stuff, as well as working with Openstack, we've also looked at modifying AID so that it can work on the offline file system. So in fact, it will work without you having to log into the possibly compromised machine.
Cool. Sorry, I can't hear you.
Would you know whether or not AID is being maintained again, because it's got abandoned for many
Well,
years?
Red Hat are teaching it on their RHCE course.
Ooh.
So if they're teaching it as something you should be using, then I'm guessing they're maintaining it. And it does support SE Linux as well, so it will detect if, I'm just looking here to see whether there's an example, but it will detect if the label on the file has changed.
Yeah, it was a spin-off from the original Tripwire.
Tripwire, that's right. Yeah. Which we all stopped using in about 2000. Because it never worked, never installed. Was there? Don't remember, it's such a long time ago. So we can see it's given us quite a big report. Obviously I'm not going to go through this line by line, but it is quite interesting. tells you things like the number of files you have, how many files have been added, removed and changed. It will give you a list of all of the files that have been added. And we installed a few packages. There we go. So it will tell you what's been removed, obviously. Those are the log files that would have been removed via the Vert Sysprep stage and haven't yet been repopulated.
And there's a lot added because you added, as part of your Cloud Init hooks, you
installed new
added the
packages.
free IPA packages.
That's right. It will also give you a list of changed files, and then just after that it tells you what's actually changed about them. So it takes dual checksums of the files, it looks at inode numbers, so it can tell you if it's been replaced or edited, change time, things like that, and it will enumerate the permissions. I didn't see any examples of SE Linux label changes, but to be fair there probably shouldn't be any. Oh, there we go. So there's an example. Yeah. It's quite interesting. If you like looking at this sort of thing, you can spend hours in here. And that is pretty much the end of the presentation, except to say that I've been running this on MicroStack, which is one of our products that we've developed, which is a dedicated private cloud environment for either on-premise or hosted by us on dedicated network and server hardware. So get the commercials out of the way. And yeah, questions, which I've got one first. Has anyone else got anything really cool that they're doing with their images that I haven't covered here that they'd like to tell everyone else about?
Don't all go at once.
I put Star Wars in mine.
We saw.
That was cool. Star Wars.
Nice. Star Wars. Let's see another hand.
Used to run hardening scripts at the end of this. So after doing installation and doing minimalization, sometimes we'd run special hardening and auditing scripts. So again, we could alongside aid. So we'd implement the CIS recommendations, which are some of the best security recommendations for Red Hat, and they provide recommendations for each of the versions of most Unixes and Windows and stuff. But we actually implemented their recommendations as a script, and we would actually roll that out at the end of our kickstart.
Mm-hmm.
So by the time and that would initiate firewalls, etc. So there's lots of extra stuff you can do at the end of a kickstart script.
Absolutely. Cool. So has that got a name? Is that a standard set of scripts, or is it a set of recommendations?
So if you go to the website, which is CIS Security, or CI Security, I always get it wrong, .org. Might be 1S.
Yeah, that's not looking right, is it?
Yeah, it's 1S.
Tell you what. That one. That one?
CI Security.
CI Security, all .org. That's them. So that's it's sort of American, but it's got a set of security benchmarks you'll see on the left, and what that does is looks at each operating system and makes recommendations. And
yeah.
Well, it's so we've implemented that. I've implemented that in banking environments and stuff. So it gives effectively a checklist which you can use to check check most things. And nowadays, Red Hat's got a lot better in implementing all those things.
Okay.
But basically, it just gives you. It's a very nice security document, which includes lots of code fragments, which basically I extracted all the code fragments and made a script out of it, and that worked really well. And that improved. And they also have auditing tool, which you can effectively score your machines. So there's also, you can also join as there's also a commercial membership bit, which allows you the licenses to run this auditing tool, which again is nice. Having worked for various sort of public bodies, sometimes it's nice to tell the auditors, right, here's at least a metric, a benchmark, a metric for you to use to actually see how good our systems are, and then we usually compare that against another part of our organisation which does really badly. And it also gives us like a risk, risk assessment against what things it's testing against.
Okay.
So it's
Sounds good.
That's a really for the last 10 years that has been a very useful Unix security website.
Thank you.
Give me an idea for Black Hat Enterprise Linux.
And then Richard.
One of the things I tend to do with this sort of thing when I'm running Linux on Linux and to use vServer because it's much lighter. And one trick that I've found useful on more than one occasion is to run something like Tripwire or AID on the host side rather than the guest. Because if the guest gets compromised, the first thing you can't do is trust any logs on it.
Absolutely.
So it's quite handy to actually have the guests in normal file system subdirectories. Where you can actually monitor them without having to go anywhere near the actual guest enclosure.
Absolutely. We used to run Linux vServer, and a long time before that we had another system called FreeVSD. Now that goes back to about 1998, and we were doing similar tricks then, and then Linux vServer. I think we're still running some OpenVZ things as well, and yeah, exactly, those tricks are great in that sort of environment because you're not even, they can't see you, you can just kind of scan them and see what's going on. So yeah, absolutely.
Use an external system server.
Mm-hmm. Yep.
Just in terms of patching these images, so when you want to update all the security packages, would you snapshot the image and then it's possibly related to the talk from Red Hat and then work on this snapshot and
So
then redirect your VMs to this snapshot?
That's one way of doing it. There are various takes on best practices around updating your systems. So at the Antwerp dojo, Cranbeer demoed a plugin for Yum. Obviously, not all updates are through Yum, there are other things that will be updated, but for the Yum part of it, there is a plugin in Yum, and if you've got 18% disk space available in your volume group, you can actually create snapshots in line with your Yum package manager and roll back if the transaction is unsuccessful. Again, if you're more worried, not that your transaction is going to fail or that you've got a problem there, you can actually snapshot your image itself and run your test suite against it, and if you've regressed, obviously you can roll back and reboot. And then some people, obviously, they write upgrade scripts that are far more granular that will test along the way. So it might depend on your environment, depend on your tool chain that you have in-house, what the actual roles of your servers are, but snapshots are very useful for an easy way of rolling back from something that failed.